Hey there, second grade scientists. Let's go. Let's do some science. We are going to look at volume. We're going to basically transfer liquids from one container to another and notice what changes. Does the volume change? Does the shape change? What actually changes? And we want to be precise, so we want to make sure we measure to the accurate milliliter that is identified. So we can use our SLAM day one. There's a digital copy on Canvas, so you should have that. Or you might be using your science notebook. There's also a PowerPoint, beautiful PowerPoint made that you can literally go step by step for each of the activities as we pour liquids from one container to another for day one. So I'm going to switch over to my camera so you can see what we are doing. Oh, beautiful. And those are the liter sets that we're using. This is the containers. And notice we have some different containers here, different shapes and sizes. And notice they actually use their mathematical name, which is very important. So we have a cube, we have a rectangular prism, we have a cylinder, like a large cylinder, small cylinder, and we have a triangular prism, large and small. So that is our liter set that we will be using. So I'll get that box out of here. Cool. And you do want to start with a beaker. So I do have a beaker for day one, which said to make sure you fill the beaker to 400, which I have accurately done. You could also color your water to make it more dramatic and you can see it better. Blue is a good one, blue, green, or red. Yes, I have yellow because for lunch I had a bottle of Gatorade. I did not finish my Gatorade, nor did I have blue food coloring on me. So guess what we're using? We're using my leftover lunch Gatorade for today's science experiment. How awesome is that? And I'm very thirsty, by the way. Anyway, there's 400, and notice anytime you look at a container, look at milliliters and see where you are. Always see what the capacity is. This one goes to 1,000, maybe just a little bit. So we're going to start with that. Very good. And I'm going to look at my SLAM day one, and I'm going to go right on through there. I'm going to ask you probably some questions too to get us started. So I have my 400 liter beaker here, Mr. Beaker, and I want the small rectangular container, which is right here. And I always like to study the container first. So I'm going to look on the side and I can see my milliliters. I want to know what these lines mean. I can see the numbers on there, but there's lines in between the numbers. So what does that represent? Very important that you identify those numbers. And it looks like the capacity is 250. It says approximately. That means close to. One thing I have noticed over the years is if you use different containers from different companies, sometimes those containers are a little bit off. So it might be off by some milliliters too. And if you spill any liquid, you will then be off by some milliliters because about 4 drops of liquid or water is about 1 milliliter. So 4 raindrops, always think 1 milliliter. So if you spill, you're going to lose some milliliters. But we can also, I have noticed that different containers by different companies and things could be off as well, since they're made by different companies. So we'll see if that happens or not. So I'm going to pour exactly, this is number one, on day one, 200 milliliters of water, in my case, Gatorade, into the small triangular container. Okay, there's 200s right there. So first of all, let me ask you this. Can I pour 200? Will I be able to get 200 milliliters of liquid into my container here? Hopefully you said yes, because there's 400. There's 200. Now here's my other question. Could I, if I wanted to pour all of this, Mr. Beaker, the Gatorade, into the small triangular prism, could I do that? Could I just go ahead and just put all of this in here? Hopefully you said no. And why? Well, this is 400. This only goes to a little bit above 250. So I would definitely spill over, make a big mess. That would not be very fun. It might be fun, but not for everybody else. So we don't want to do that. What we do want to do is what number 1 says. It says pour exactly 200 milliliters of water, in our case Gatorade, into the small triangular container. So let's do that. And I'm going to get my eyes low here so I can actually see what I'm doing. I want to be accurate. I'm doing it slowly. Boom. Pretty good. All right. So now, look how different this is. Do they have the same volume right now? I had 400. I took 200 out of here and I put it into here. Do they have the same volume? Now I know you're going to say, well, this one must have more because it looks like it has more, right? But they are actually the same because there was 400. I took out 200. I put 200 here. So how much is left in here? Well, you can totally see that. So they have the same volume, but they're different sizes and shapes of containers. So you always got to be careful. This one looks very promising. Like if I said, if you want some Gatorade, well, I'm going to take this one. It has more. Well, guess what? They both have the same. So that's very interesting with volume. Takes the shape of their container. How much space is it taking up? That's volume. This has more space. So there's going to be less. It looks like there's less in here. So there's less space. So it's going to be taller on this one. Very interesting. Now, number 2, how will the volume of water in the small triangular container compare with the water in the large triangular container? So we're going to pour exactly 200 milliliters of water, this case Gatorade, into the large triangular container. So I'm going to take what's left of Mr. Beaker. Here is our large container. Notice this one goes up to 500 milliliters. Okay, so are they going to look exactly the same? If I put the rest of Mr. Beaker, which is 200, which is the same that's in here, will they look exactly the same? What do you think? That's called a prediction. Let's find out. So I'm going to go ahead and put 200, and it should go to 200, hopefully. Like I said about sometimes the containers are not calibrated correctly. And I could have spilled some liquids too. Say goodbye to Mr. Beaker. We're not going to see him for a while. So what do you notice? They both have 200, but are they at the same level? If I was to go to the same level, that would be 400. Well, we know we didn't. We started with 400, but we put 200 in here, 200 in here. So write down what you notice. Okay. And it is about 200. It could be a little off, but it's close enough. And the interesting about these beakers, it's not as accurate as a tool like this. Graduated cylinder is a lot more accurate because it goes up by milliliters. 1, 2, 3, 4, 5, 6. Sometimes these beakers, they skip by 50s, or they'll skip by hundreds, or even thousands, depending on how big it is. So they're not as accurate as if I was using a graduated cylinder that actually goes up by 1 milliliter at a time. Say that 5 times fast. 1 milliliter at a time. Anywho, so that's a little bit about what type of tool you're using. Okay, so moving on. Pour the 200 milliliters of water from the small triangular container to the large one. Okay, so we're going to go ahead and pour. This is number 5. So what should it go to? Now, if it's just below, like I said, they might not all be calibrated perfectly. I've been finding that out, but that's okay. Plus, we're not using a graduated cylinder, which is a lot more accurate. We're using containers that skip by 50s in this case. These go up by 50s. Some of them go up by hundreds. So it might not be totally accurate. And if we lose any water, I still have drops of water, Gatorade, in there. Okay. So that was number 5. We poured everything in there. So how much water, Gatorade, is in the large container, triangular container? And it should be, and notice we've been using this word approximately on these containers. So you could say approximately or close to 400 milliliters. Now, if it said 300 or 200, I would be asking all sorts of questions like what happened to all that liquid, but it's very close. Cool. So now we're going to pour number 7. So you recorded, should have been 400 milliliters for number 6. Number 7, pour 250 milliliters of water from the large triangular container into the small cylinder container. So here is the small cylinder container. We're going to transfer 250 milliliters. Okay. Let's mark my place here. So first of all, can I put 250 milliliters into the cylinder? So make sure you check that. This does go up to approximately 500. So I know I can do it. I can put at least 250 into here. Could I put all of this into here? Absolutely. It goes up to 500, so I would be good. But that's not what it's asking. We're going to put 250 into the container. Okay, 250. All right, and notice how they look different. Okay. So if I put 250 in here, how much is left in here? That is number 8. How much water is left, in this case Gatorade, is left in the large triangular container? You'll have to do a little mathematics there. Okay. Okay, moving on. Pour the remaining water from the large triangular container into the large cylinder. So here's our large cylinder. Woo-hoo-hoo. Let's look at our large cylinder. That one goes up to 1,000 milliliters approximately, and this one does jump by hundreds. So less accurate because now we're jumping by hundreds of milliliters. So it's the accuracy is going down. Okay. If I wanted to get a precise number, if I was looking for like 783 milliliters, this would probably not be my best choice. I'd want to use some sort of graduated cylinder for that. So pour the remaining water from the large triangular container into the large cylinder. There I go. Compare the volumes. So, are they the same? They're definitely not. Plus, we know that. We know how much was in the large triangular prism. We know how much was in there. You did a little bit of math. So you know it didn't have as much because there's 250 in here. Okay. So how much is in here? Hopefully you said 350. And again, not as accurate, right? So we have 250 in here. I'm sorry, this would be 150 in here. That's called math. 250 plus 150 would be 400. Remember, we started with 400. So 250 and we have 150 in here. Okay. Definitely has a little bit more. All right. We know they're not the same. Now pour the water from both the small and large cylinders into the small cube container. Ooh. Here's our small cube container. Okay. Check the volume there. So this says it goes up to 500. All right. This was 250, right? Can we put 250 in here? We absolutely should be able to do that. And I'm checking on here, and it did go to 250. Okay, pretty close. Now, we had how much in here? Do you remember? When we transferred from the large triangular prism. So we had 150 left in here. So if I add that to here, I should get back to my original liquid capacity of 400, or close to there. Woo! And look at that. Right on 400 on my letters, on my capacity there. My numbers, right to 400. I love when science works. So very good. So I'm back at my original. I haven't lost anything. You know, like I said, when we transfer from one container to other, if they're not calibrated at 100%, they could be off by a little bit. But notice this one's looking pretty good because it's 400 right on the money. Yay! So in the small cube, that's number 12, you should put 400. Now it says pour 200 milliliters of water from the small cube into the large cube. This is actually a rectangular prism. So rectangular prism into the large. And the first thing I should have done was look at the capacity of the large cube, which it does go to 1,000, so approximately 1,000. Okay. Notice it was different, wasn't it? So this one, the volume is the same, but it's a lot lower. Why is it a lot lower than when it was in here? Again, this was smaller space, so the water went up, so it was taller. There's more space here to spread out, so that's why the liquid isn't as tall, but there's still 400. So I check there, yay, it's at 400, so perfect. So just because it was taller doesn't mean it had more liquid in this, the smaller rectangular prism. All right. That was number 13 and 14. You wrote down your observations. Okay. A lot more room, a lot more to spread out. Same volume, but different size. Finally, pour all the water from the containers back into the original beaker. What did we observe? So we're going to go back to hello, Mr. Beaker. Mr. Beaker is back. And wouldn't you know it, I am back to 400 milliliters. Wow. Why does it have the same? If it didn't have the same, if you are not close to 400, maybe talk about why. You should be if you did everything. Did I make a mistake? So if you think I made a mistake somewhere, you guys can talk about it. But I feel good that I'm back to 400. It got a little tricky there when I was going from 250 to this container. So the whole idea is transferring liquids to different containers. Your volume is not going to change. The size and shape of the container might look like it's changing, but it actually isn't. Volume is just the amount of space something takes up. In this case, liquids. And one of the physical properties of liquids is that they take the shape of their container. So that's why that happens. So if I take let's put 200 milliliters back in here just to show my point. So my point again was they both have 200 milliliters in them. This one looks like it has more, but the space is less, so it pushes that liquid up. So it has to go somewhere. It pushes the air out, and that liquid has to rise. It has to go up because it's filling up space. There's more space here. It's a little wider, so it doesn't go up as much. It's not going to go to 400 or whatever. There's only 200 in here, okay, because there's more space. It's a lot wider container, even though this one looks like it has more. So you always have to check your numbers. If you're not sure if you have a container that doesn't have numbers on it, you'll definitely want to get something that you can definitely measure so you can be accurate. And what did I say was the most accurate instrument? If I was trying to be precise to the milliliter, would I use a container like these? I would want to use a container like this, a graduated cylinder. If I wanted to be precise right down to the milliliter, that's what I would use. Wow, that was day one. So that was, whew, that was a lot of work. So hopefully you guys enjoy that. Hopefully you understand a little bit more about volume. Day two is going to be a little different because you know what? We can find the volume of solid objects too using a graduated cylinder. So if we have a solid object and we want to know its volume, how much space it takes up, we can actually use a graduated cylinder and a very special method of figuring that out, which we will do at day two. So thank you guys for hanging in there. Awesome lab, awesome work today. And we will see you next time for day two, finding volume. Let's go.